Okay.
What is the essence of life? What does every cell, every molecule need to survive? The answer? Energy. Hi, I'm Sukhjot. This is Collen. This is Dillon. And this is our idea. An idea that comes around once in a lifetime, and an idea that will change the way we consume energy every single day. According to Roland Rosario, head of R&D at Veteran, there are three problematic concerns with how we consume energy in the state of Indiana today. First is the unpredictability behind high peak load energy times. Second is the inability to alter consumers' consumption behavior of energy. And thirdly are the economic inefficiencies caused by these two variables. To better illustrate this, let's take a look at this graph. This graph illustrates the traditional fixed rate model. If we take a look right here, this is what's known as peak load demand. This is where demand exceeds supply. Therefore, utility companies have to purchase energy at a higher premium cost to compensate for that higher demand. Inversely, if you take a look at this section right here, this is off-peak. This is where supply exceeds demand, resulting in a dead weight loss because so much energy is produced and it goes to waste.
Now, Mr. Rosario told us that the holy grail to solving these problems is disaggregation. So that's exactly what we're proposing we create an app to do. What we're going to do is it's going to be able to modify consumer behavior and also allow utility companies to institute a time of use pricing structure. But how are we going to do that? Well, by putting sensors on the mains flowing into a home or a business, we're going to be able to track the amount of energy that's going into that establishment. Using Keter as a back end, we're going to be able to create two different user interfaces. The first one's going to be for the utility company, where they can track on like a geographic map hot spots in the area, who's using the most energy. Maybe they can figure out why they're using the most energy and come up with plans in order to modify that behavior. The other user interface is going to be for the end user, the business owner, the homeowner. And what they're going to be able to do is track what's using the most money, what's the most money to run, when it's being used, and it'll show them, if we have time of use going, when the optimal time to run these things is, so that they can make better environmental decisions as well as economic decisions. So, let's talk about time of use pricing real quick. Currently, our model that we use is just an average rate. It would go right through the middle of this graph, and that's no matter the peak, you're paying the same amount of money. Time of use changes the price based on the load, so by charging more during peak hours, you're able to give people a reason to turn the electricity off and plan better to use their electricity during off-peak hours. By charging less than the average during off-peak hours, you create an economic incentive for these people to make wiser decisions with the way they allocate their electric resources.
The electric industry is a $319 billion industry with an annual growth rate of 13.5%. Now, there are several market trends and factors that we took into consideration when trying to solve this problem. The increased demand for time of use pricing, the increased demand for utility companies to have real-time data of what they're using electric-wise, and then government regulations coming into effect trying to reduce and help efficiencies. We have 9 different utility companies in Indiana, but we want to start by targeting the first 4 big ones. These are the 4 biggest in Indiana, and all 9 of them account for about $9 billion annually of the $319 billion market.
So how are we going to do this? To better articulate how we're going to create value for consumers, we cultivated a business model canvas that articulates how we're creating value, delivering value, and how we're going to monetize this to ensure a long-term business model. However, due to the constraints of the PowerPoint, the compensation section is going to be on the next slide. But in order to understand the entire business model canvas, we need to take a look at this section right here. This is the value proposition. Value proposition we're creating for users is we're minimizing household costs by providing them the individualistic APIs for each appliance and how much energy they're consuming at different times of the day. Inversely, for utility companies, we're providing them a platform to incentivize consumers' behaviors to alter and predict higher peak load times and off-peak times. Now, in order for us to provide this value, we need to execute a few key activities, which is install sensors on all breaker houses to disaggregate this information, develop both a UI and a UX for both the utilities and the user interfaces to provide the best functionality and make it so intuitive for them to use. We need a UX and UI maintenance team just in case there are any issues with the back-end servers. And we need to integrate with the existing legacy systems that Vectron has today. In order to execute these key activities, we need a few key resources. Taking a look right here, we need a software operating system, we need sensors, we need Keteris backend to power the disaggregation aspect along sides of the sensors. We need cloud-based servers to store all the data. And lastly, we need an app store for the product to be on.
So our company has two customer segments, the first being the utility company, and then the second being the end user, the consumer, the homeowner, or the business owner. Now we're going to target them with a group of support teams, which are going to be provided by Vectron, but trained by us. They're going to have their field technicians out helping do in-app support, in-home support with the software, with the systems, and making sure that everything works through the app and is integrated with their house. Now we're also going to provide in-app recommendations on their phone about maybe every month or every week, telling them that they can save money here or help reduce their costs by turning this off during the day. Now, the big problem with this is we've got to be able to educate our customer base and tell them why they should adopt this, why they should use it. So we're going to use Vectron's marketing to educate the customer, use social media, different forms of it, our page, their page, to get the word out. And then we're going to also use local news, local media, and then local testimonials telling them why you should use it.
In order to make sure we're providing the user with the optimal amount of value that we can, there's a few key performance indicators we're going to be watching. One of them is going to be watching the power factor using those sensors, which will basically measure the efficiency with which the energy is being delivered to the end user. Beyond that, we're going to be watching behavioral patterns by logging data about usage across the whole area that this has been implemented. From that, we can use behavioral predictive analytics, any number of other things that we can do with that data, finding patterns and giving recommendations to the utility company about the best way to buy electricity in order to mitigate those dead weight losses. But in order for this company to stay profitable, we need to have a good way to capture that revenue stream. So, the cost structure is pretty straightforward. Of course, you're going to have your usual overhead items, rent, salaries, raw materials, that sort of thing. But in order to start up, we're going to have the additional costs of software support to develop the app, and of course we're going to need the servers to store this huge amount of data on, but storage servers are pretty cheap, not a big deal. As far as revenue streams are concerned, we're going to be charging an upfront cost in order to install the system of, it's going to be $15 to the end user and $5 to the utility company, and that's going to cover the hardware and the labor to install that hardware and get the system up and running for them. After that, in order to sustain our company, we're going to have to charge a subscription fee, which will be $2 to the end user, $5 to the utility company. So, whenever this goes into effect, it'll be Vectron-wide, or whatever utility company's whole territory. So if we work it out to a 100% adoption rate, that's going to be about $15 million in the first year.
So in conclusion, our value proposition is we're minimizing household energy costs through the disaggregation of individualistic appliances and their real-time energy usage. This is going to benefit both utility companies and end users by altering consumer energy consumption behaviors and shifting energy peak load and off-peak time consumption. Thank you.
Wow.